All right, next up. Good job, Valerie. Okay, so our next contestant is... Now, is this person here today? I don't think so, right? Okay. So I got this list from our list, but I think he actually stopped coming. So Lou is here, right? No? Oh, there you are. Okay. Cool. Which one would you like, Lou? All right, right in the middle. Okay, write a expression that returns a random integer between 23 and 68. So this one you do have to come to the board.
Oh, no.
We've worked with random numbers. Remember, every game has randomness in it. We had to learn our random numbers. Can anyone do this? Maybe I didn't make you guys practice this enough. I think you said it.
Oh, shoot.
Does anyone want to take a guess?
You might get half credit.
Yeah.
Just in case you don't get it.
How do you make a random number, you guys? You right? And then what does that always give you? It gives you a random number between 1 and 0 and 1, remember? It gives you a random number between 0 and 1. So then you have to multiply it times what? Your range. So how many numbers you want, you multiply it by. So what's our range in this one? Right? That's our range. And then 23 is our offset. Okay, so remember you multiply it times your range. And then you add in your offset. Remember that what that does on the timeline.
I remember you telling us that.
Yes, remember? This would be 45. So remember, if you take a number between 0 and 1 and multiply it by 45, you're going to get a number between 0 and 45. And then when you add the 23, that moves this range up the timeline to go from 23 to 68. Okay? And then last but not least, what do we need to do to this number? It gives us back a decimal number, so if we typecast it to an int, it will drop those decimal places for us.
So within the parentheses, you have a 0 or 1?
This will give you point something or other. This will give you 45 point something or other. The integer drops the decimal places, and then that adds 23 to it.
But, so you'll not have anything within the parentheses? I just don't remember.
Oh, yeah, so this is a method call. Remember, that's your method call.
No. After random, you have just parentheses?
Yeah, so this is your method call. Because he's a method call, remember, if there's nothing in there, you still have to put the parentheses for a method call. Whenever you call a method, remember. Well, the answer's in here too, right?
It's nice to have it on the phone too.
So we'll look at it later.
Oh, I used something different in here, but that's okay. You guys will have both answers. All right. And next person is Aaron. Aaron's here. Okay, Aaron. Okay. All right, so we just have an expression here, and you just have to tell me what it evaluates to. So remember your order of operations. And you can have a piece of paper and pencil out if you need paper and pencil. No. Let me think. No. Let's see. It is 24.
Why did I raise my hand, man?
Order of operations. PEM does. What does it do first? Parentheses. So what does that evaluate? 2. Then it does division, multiplication, left to right. So it'll be 20 divided by 2, 10 times 2, 20, and then it adds 4. Okay, so just remember your order of operations. And remember, would this one do int math? Remember your int math as well. An integer divided by an integer is an integer, and it drops the decimals. So just remember those two things, your order of operations and your int math. All right? All right. Next up, we have Gabriel. Okay, Gabe. Oh, the other Gabriel. Yes. Yes, we have 2 Gabriels. What is it? Okay. All right. When you write system.exit, parenthesis, in your code, it terminates your program. What Java class is the exit method from? And you can tell just by looking at it. You got this, Gabriel. What is it? Me, no. This is not good. We should know this. You can tell just by looking at it. Jason, what is it? It is system. Remember, class names always start with a capital letter. Okay? And this happens to be a static method because we're using the class name to call it. I mean, yes, we haven't learned about static methods, but... So remember, class names start with a capital letter. If you have a class name, call a method, that method is from that class. Okay? So good job, Jason. So it is from the system class. Let's roll again, and I'll get the points in. All right. With ya.
Some good job knowledge for 4.
All right, the main method header is written. Oh, and this is a writing on the board one. I bet you can do this one. Now remember, I don't make you memorize things, but this was a 4-pointer, so. And sometimes we remember it by default, hopefully. And you can erase the other stuff, actually. Here.
I just looked at this too.
All right, let's see. So hopefully many of you could think, you know,
I just don't remember the order, guys.
a lot of times we check mark that box or we copy and paste it, right? But remember, I don't make you memorize this stuff. But sometimes we can remember just because we've seen it all semester.
I'm surprised nobody's like opening up the book and they'll steal it.
Now, this one might be a hard one to steal because she got it mostly right.
I'm pretty sure they did.
ARG, I might be mixing these 2 letters up.
To tell you the truth,
Public static main, public static void.
there, yay, you remembered. And then that's not system, what is that? Public static void main. You got the capital S right. 6-letter word, starts with S. I think she got it mostly right.
Don't tell me, don't tell me, don't tell me.
And maybe because we never took in some console arguments, we...
is what happens when you always
There,
pick that box.
yes. She got it. Yeah, put that in there. Wait, put it up above though. But good. Yes, she got it. Public static void main string args. And then the only capital letter is with the word string because it's a class name, right? Yes. And just remember your brackets, and she did. So now that we know more about programming, what is this? This is our return type, right? It's returning void. What is this? Of an array of strings that we're passing into the main method.
What was the R again?
It's just a variable name. So they just, well, actually, it usually ends with an S here. So that means when you're first starting your program, you can actually give it some input, but we just never actually did that in here. Okay.
I was afraid I was going to go dyslexic.
But good.
And switch the letters.
Because remember, at the beginning of the class, that was a magical line of code, but now we can understand it better, right? Okay. Keep on keeping on here. Okay, so good job, Alicia. All right. All right, Evelina, she's here. Which one would you like? Yes.
Some good Java knowledge for 2.
All right. We like this category. 10 bytes has how many bits? Just remember how many is in 1 byte and then... Yes, good. Yes. So 8 bytes, 8 bits per byte. So you just multiply it. Good job, Evelyn. Okay. Okay, Michael is. Oh, yes. Right there. Which one would you like, Michael?
Let's go a little bit going.
Okay, awesome. All right, so we got a truth table. And we went over this when we went over our logical operators. So remember, we have A is a Boolean expression, B is a Boolean expression. This is how we combine our Boolean expressions.
So the first one is should I and, right?
So what do you think it is? But, in other words, what's in place of that question mark? What should be there?
So it's and like and sign to make them true. And then the other one is the one that takes the first one to make one false. And then am I doing this right?
Gabriel, what is it?
Or?
It is the OR operation.
Oh my god. I thought it was the to make it true or false. True, like if true is
So if the
true,
first one's true and then the second one's true, it's true. So if, and either one of them is true, it's true. And then if they're both false, it's false. That's the OR operation.
Yeah, those are the rules for just the
Oh.
OR operations.
I thought you were talking about this, like I thought you were talking about this with like the at and for the first
Oh, the ampersand. Yeah, it is like that.
and then for the second one it should be this one.
Yes.
That's what I thought you were asking.
But this is our Boolean values. These are all possible cases for A and B. And then those are the outputs. If A is true and B is true, then your output is true. This is a truth table. Actually, the truth table is the basis for all computing. You understand truth tables? For all logic design, this is the basis of our computers right here. So that's our OR operation. But you could still steal, so pay attention, yes. All right, Haley is here. Which one would you like, Haley? Okay, another cup of Java for 3. All right, so we have a loop, and we're going to have some output. So you could actually just tell me what the output is going to be. You got it. To see where the loop starts, where it stops, and then what does it output? You got it, Haley.
I know what it's doing.
What?
Almost, but look at that second line in the loop.
Did he get it? Oh, she?
There's one little trick in there. The second line in the for loop there does something. Who had their hand up first? Was it Lithia?
Yeah, it was me. It was me.
Okay, Lithia. What is it? What does it print out?
3579.
Almost.
Damn it.
I don't know if I can give away points.
Oh, 13579.
So it starts at 1, and why does it count only the odd ones? Do you guys see why?
You're adding 2.
We do something we should not do in a loop, but we do this in this just to like show. You should never manipulate this index or this I in the loop, but in this instance we did. So it skips every 2. So remember that it starts out at 1, this makes it 2, this makes it 3. Prints out 3, this makes it 4, this makes it 5. And then it'll stop at 9 because when it gets to, 11, then the Boolean statement's false.
Shh, don't lie. I need these points.
That's okay.
How many was that?
I don't know. How many was that, actually? All right. Sarah, you got it. And we've seen this before on a previous Jeopardy, actually. And I think it was a test question.
Oh.
This is a good test question. It's actually in your book, too.
Oh my God.
So what do you think, Sarah?
Oh.
All right. Do we have anyone that wants to answer this guy? You guys have seen this before. Jason, what is it? No. Lithia?
It cannot compute the double.
Right. Good. Remember, switch statements can only be used with integers, characters, and with Java 7 strings. You can't switch on a double. It doesn't make sense. Doubles can't check equality.
How many was that? 4?
Okay, we're gonna have to let other people have a chance here,
Okay,
Lithia.
I'm sorry. I studied like
But no one else did raise their hand on that one. So.
It's weird.
Okay, Aaron is back there.
Some good knowledge, or some good job knowledge for that point.
I was going to say we have some 5-pointers. Some classes, they always get the 5-pointers first. All right, so a 1-pointer, blank is the physical aspect of the computer. Good, yes, the hardware. Thank God we got that one right. Yeah, basic computer questions, just a few. These are questions you should know just because we live in a world of computers and you should know these, okay? You should know what hardware is and what software is. Yeah, kind of like that. A lot of these are actually from test 1 too, okay? And Samuel is right there, okay. Okay, Samuel, which one would you like? Good. All right. So we have this code blurb here, and the user types in hello, and I say, hey, what's going to be the output? This was an extra credit problem when we studied strings, actually. What do you think, Samuel? You got 50-50 here. So we can't steal this one because this one's a 50-50-er. What is it? What is it? Same? Actually, it is different. Now, how come it's different? Like, if they type in the word hello, they are the same values in the string. But when we use equal equals with objects, what are we checking? We're checking their references. Yeah. Actually, we get more into that in the second level programming course. Okay. So this is legal in Java, but we're checking if they're pointing to the same string in memory. Do you remember our visual, our picture? All right. Just remember that when you check strings for equality, you have to use a method called equals ignores case. Okay, remember the string 1 dot equals string 2? You have to use a method. Yes. So, whenever you check two objects, including strings, you have to use a method, not equal equals. And that one was harder. That's a 5-pointer. Now just note that the 5-pointers will not be on your exam. They are harder questions, right? Okay, so Lee is not here. And Jason. We know Jason's here. And actually, well, okay. So which one would you like, Jason? Okay, good. Okay, we've seen this one before.
This one again. It's this one again. I don't like there's a guy right here.
Maybe Jason will get it. I think Jason will get it. So in other words, you just have to translate that saying can't get a driver's license if you're 16, and you can get a driver's license if your age is greater than or equal to 16, and which of the code correctly translates that?
It's in the book.
Actually, this question was from the book, right? Oh, Jason will get it. Which one is it? Yes. Remember that all of them do that. Good. Actually, I should have changed it, right? Now, what is a 5-pointer? The 5-pointers, remember, I try to make as 5-pointers.
So if you answer just one?
Yeah, so if you answered one of them, it wouldn't be all the way right.
So you get one.
All right, Rebecca. Okay, cool. All right, so this one you do have to write in the board. To write a method that takes 3 numbers and returns the average of the 3 numbers. You don't have to write the whole main, you just have to write the method.
The header and everything or not?
Yeah, the header. You can write it, Good. See, she studies all the time. Very good student. Good. Remember, all of our methods more or less look the same way. So, and you can continue on the other line. That's okay. You don't have to erase it. You got it. And Good, Rebecca, good. Good, we remembered our semicolon. Yay. Awesome. Just one little tiny syntax error, but it's mostly right. I think you should get it. Just remember that you have to declare all of these int.
Well, I thought you could go to each one.
Java doesn't like that. He's very strict.
So you need to put
In front of all of them.
Oh, okay.
I feel like
Eclipse would have yelled at you for that. You would have got it eventually.
it probably didn't dawn on her. It's harder to write it.
It is harder to write on a
Because you're always
whiteboard.
on your- and then you just transfer
It is harder to write it on a whiteboard because the IDE helps us a lot and we take it, you know. But I think that is pretty nice. That's very well done. So she takes in the 3 parameters. She finds the average. I really need to fix this thing. Another way to write it. Actually, yeah, you could write it many different ways. You could write it in one line, actually.
I'm lazy. I would have written all of that in one line.
Yeah. Remember that you could have written it like this, too?
I would have done like return in parentheses a plus b plus c. Plus
Right.
3, and then the
You could write it like this, too. And then you wouldn't need these 2 lines. So remember that you could just tell it, hey, find this answer and return it. This would probably be a way that you would see online. This is how most people would probably program it. But the other way is still correct.
Maybe it's easier to change these numbers.
Okay. All right. Good job. Good job, Rebecca. And how many points was that one? 5. It was a 5-pointer, right? Okay. Good. That is good. You got some padding, and I think you'll do well on the test anyway. And Guillermo is not here. All right, Andy is here. There you are, yes. Okay, which one would you like, Andy? Okay. All right, so we have a method that looks like this. This one you could tell me what's wrong with it if you want. But you have to fix what's wrong with the following method header. Yes. And then get rid of the... Yeah. Okay, not too bad, right? This is actually the... well, actually it's just mixed up. All right, awesome. That one's actually pretty easy, right? So Donica is... Oh, back there, yes. So which one would you like, Donica? We're running low on points here. Do the following 2 statements in 1 and 2 result in the same value in sum? Note that the difference is the pre-increment operator and then the post-increment operator, right? Actually, we've seen this question before, I believe. What do you think? 50-50. Yeah, you can't steal 50-50s. That's just... Okay, time's running out. What do you think? Okay, 1 more second. You better just give an answer. Sometimes you just have to guess. Then we'll explain it. And what is it, class? Yes. Because remember that The update operation, remember this is called your update operation, happens at the end of your code. So whether you're pre-incrementing your update action or post-incrementing it, it doesn't really matter for this type of update action, right? So in this case, it didn't really matter. Okay. All right, cool.
Oh, man. I'm yellow, though.
All right, Christopher is back there. Yes, Christopher. Okay. All right, what are our 6 comparison operators? Not only in Java, but in other programming languages too.
Or and
Well, how can you compare 2 numbers?
greater than, less than, or
You said equals.
greater than or equal to,
Okay, greater than or equal to, and then less than or equal to. Yay.
What about the non-sign? Is that comparison?
Oh, yes. And then not equal to.
I got 1 point.
Okay, so remember that these are our comparison operators. Now, and or are actually called our logical operators. Because we're not comparing 2 things, we're combining 2 Boolean expressions. Okay? All right. I think that's pretty good, though. All right. Okay, Douglas. Which one would you like? And actually, we do have, well, okay, so which one? Okay. Which of the following is the correct expression that evaluates to true if the number x is between 1 and 60, or the number is negative? So. B. Yes. Do you guys see why?
Yeah.
So you know that this has to be the or, because it says or the number is negative. So you know that this one's out. Okay. And this one's out. And then between 1 and 60. Okay, cool. Good. Okay. Good job. Gabriel, our other Gabriel. And I know we're running low here, but we have enough. Actually, there's less than 25 people in here, so we can actually have 2 questions each. So we'll finish up this one, and then we'll go to the next PowerPoint. Okay, awesome. This is a 5-pointer. So when did George Boole live? And you could probably might guess this.
The process of elimination.
And you remember George Boole contributed to Boolean, algebra? Like the Boolean algebra, Boolean expressions. That's where we got Boole, our Boolean values from his name. You got a 1 in 4 chance. And we won't steal this one. This one's No, the ones with multiple answers, it's not really fair to steal. I don't think. Which one do you think?
Obviously, it's not A. When was it?
Hey, Gabriel has to answer. All right. What do you guys think? Now you have to kind of think. This was before computers. How How did he contribute? Well, electronic computers. But he created ideas that led to the development of Boolean algebra that led to, you know, programming computers. Yeah, good job, Douglas, actually. That was a hard one. That's why it's a 5-pointer. Okay.
That was like out of left field.
Yeah, I know the 5-pointers are like that.
Hold it.
All right. I don't know.
All right, Paul.
Okay, let's go with the cup of one, man.
What is it? Right here?
Let's go with one cup.
Okay.
One cup. That's a good choice.
All right, so we have 45 divided by 4. What is our answer?
What up?
Wait, is this it? That's kind of a trick question. You don't.
What do you think?
Depends, right?
It doesn't depend. If I had that in my program, what would it output? You know this.
What? You're just freaking me out.
Yeah, no stealing this one.
Are you serious? Maybe I still understand.
He got it. Come on, Paul.
B?
What is it?
B?
Yes, B as in boy. Because it is int math, right? So no decimals. Good. See, I knew you knew that one. All right, Anthony is here. There he is. Which one would you like? And I know we're running low. What is the first thing that you do before writing any code? That is a good answer. And then we put our, we write our name and then,
Please.
and
My hand is set.
I'll still give you points for writing your name. That's good. But what else do we do, class? We write our algorithm.
When the date becomes an algorithm.
Well, this is what you should do. I know some of you try to skip this step. The name is still okay too. You should always write your name on there too, actually. Okay, Travis is not here, right? I think so. We could still have a couple. Alejandro hasn't gotten called. Jimmy is right back there. No. He's not here, right? Okay. Yeah, I know. And then Juan is not here, right? Okay. Actually, who hasn't been called? I think just Alejandro, right? There you are. Cool. Now he's good. Okay, so what is the output? You should get this one. Remember your order of operations. This one's an order of operations one.
Okay. Oh. Oh.
Yes, I think I know this one. But he might get it.
Yeah, he might get it. He's pretty smart. This one is a harder one.
Oh. I think I know.
I know what it's doing, but I don't know the answer. That's what I'm saying.
Use your calculator.
Use your calculator in here. Sarah, what do you think it is, Sarah?
3.
It is 3.
Because it's ceiling. And then that goes
So remember, when you ceiling something, what does it do?
10. And then you do absolute value. And then when you square everything, it's still an int. So it goes drop back down to 3. Right.
So when you ceiling negative 9.3, it goes up. But we're negative, so up is negative 9, right?
And then you absolute value.
Absolute value. And even if you didn't memorize these, you could figure out what those methods are. We've seen them before. Absolute value makes it 9. This typecasts it to an int. And this takes the square root of 9.
So do I think it's 4 points?
Mm-hmm. Well, you didn't say 0.0. Just kidding. I'm just joking. Yeah, you got it right. But remember that doubles are, you know. Yes. Yes.
I'm happy.
All right, and then Julia is not here, right? All right. All right. Do you guys want to play again? Everyone want to play again? Okay, good. Let me write Sarah's points before I forget. And let's roll again. All right. And we got Julia again, but she's not here.
I wonder if it's going to go exactly backwards.
It shouldn't. It's supposed to be random. And Aaron wasn't here, right?
Aaron is.
Oh, I know. It was Aaron that is here and Jimmy's not here yet. All right. So brand new board. Now remember the 4 and 5 pointers are more difficult. I did make them. Okay, what do you think? For 5? Okay.
Dang it.
All right, so we have a...
Oh, crap.
Now remember, we studied this at the very beginning of the semester. Binary math is super easy. All you have to know is 1 plus 0. Yeah, and 1 plus 1. And why is this important? Yeah, basic knowledge of a computer. Remember computers, it gives us an appreciation of what a computer can do too. Because remember, that's all a computer can add up is 1 plus 0. And 1 plus 1. So what do you think? You can come to the board if you want to. Okay, does anyone want to take it?
Can I try it?
Yeah, Haley.
I'm probably going to get it wrong.
What? No, don't go in saying that. Say I'm going to get it right. Go in positive.
You're going to get it wrong. That way when I get it wrong,
Yeah.
you don't know that.
No, you have to go in positive. Always positive mindset.
I like to go with a negative mindset. I do bad. I'm like, oh, whatever. I do good.
We can write it. We can write the problem.
I think what she's suggesting is
Now that is all one number and all one number. I just put spaces for readability. So it's an 8-bit and plus an 8-bit.
do good, you'll do good. And if you say you're going to do bad, you're more likely to do bad. You know what I mean? I'm going to do awesome.
I know what you're saying. Oh,
Good.
I do reverse psychology on myself.
I'm going off the facts.
Oh, you're translating it? You're not translating it right though.
I'm not? Okay, then I
Just,
give up.
just
I don't
add
know.
it.
I don't know how to do this. Never mind.
I thought it.
You guys. Lithia, can you do it?
We're going to add it, right? It would be
What's 1 plus 0?
1. Oh, that's all.
Oh.
1.
What's 0 plus 1? 0 plus 1. 1. 1. What's 1 plus 1?
2.
2.
2.
You guys know 1 plus 1 is 2. You got in this class with Math C.
I thought it was binary.
It is binary, but 1 plus 1 is still 2. How do you write 2 in binary? This is the 1's place. This is the 2's place. That's how you write 2 in binary, but 2 is still 2. So you write down the 0 and you carry the 1.
So it's 0 carry 1, then it's 1 0.
Just like when you do 9 plus 1, you write down the 0, you carry the 1.
So it would be 0 again, carry the 1. 0 again.
Right? 0 again, carry the 1.
0 again, and 1.
Okay? Remember, binary math is super easy. You know. Decimal math is 10 times as hard. See, they should teach you in elementary school how to add this way first.
Petition for that.
Actually, some elementary schools are teaching this now. So.
1 plus 1 is 0.
All right. I remember we teach, or we go through a lot of that in computer architecture class, CPSC-42. All right, Anthony is over there. Good. I'm glad the people we call later are now getting called first. Okay, Anthony, which one would you like? All right. Cool. All right, you got a 1 in 4 chance here. Arrays are treated like blank variables in Java. Take a guess, Anthony. What is it? D? No. What is it, Haley? Or not Haley, sorry, Rebecca. In my head. It is A. It is a reference type. Now, what does that mean, reference type? Do you guys remember what that means?
You're referencing to an index.
Right. Well, you're referencing to a point in memory. So what does that mean for us? When we pass in an array into a method, it changes the actual array in the method. Remember that? I think that one was 2, actually. Maybe I should have made that one worth more. Yeah, you get 2 points. Okay, Christopher is still here. Yep.
Java basics for 1.
All right, awesome. 50-50. The following code is valid and won't give you any errors. Yeah, true and false. It doesn't make sense to steal it. It is actually false. And why is it false?
That's a double. The
Right.
number can't be a double.
Remember, we're declaring these as integers. And then we're trying to set that integer to a double. And remember, you can't put a big number into a small cup. You can go the other way, but you can't put a bigger double into an integer. Okay. Okay, Gabriel. Mejia. Right on, good. All right, we said what output is going to be produced by our following code? What do you think? No, there is. 0, 1, 2, 3. Oh. Wait, what was your answer? Wait, say it again. I think you had it, actually. Almost.
There's no such thing as 3 or 4 because it's an error. All right, then. How about the first line would be 14.2, second would be 11.3.
Almost. Not. I think your first answer was better.
Was it? Because my first thought is that
Where do we start indexing?
error.
So this is 0. This is index 0. This is index 1. This is index 2. This is index 3. The other one is an error. So it'll say wait 3 is, 11.3. And then you'll have an index out of bounds error, that big red error. Yes. All right. All right, Jonathan is back there, yes. Okay, which one would you like? Okay. All right, the acronym SDK stands for what? Now you know what the JDK stands for, SDK? Same thing. Yes, good. Yes, software development kit. Okay, good. Remember, that's what we downloaded. So the JDK is a SDK. It is a software development kit, right? So it's for us developers. Yes. It is one of many SDKs.
Oh.
Lifty was like,
Let's see, Guillermo was actually not here, right? Okay.
Lifty was almost here again.
And then Aaron was, oh yeah, Aaron's here. Which one would you like, Aaron? For 4? All right. We're going to assume something. And then we want to figure out this equation. So you might need a piece of paper, unless you're good at doing this in your head. Oh, you can use the whiteboard, of course. Actually, does it really need that assumption? I don't think. I think I rewrote this. We don't really need the assumption. Or maybe we do. Number 1 is an integer. All right. Actually, no, we don't need that assumption. So, Aaron, what do you think? Lithia, what do you think? Yeah. You just have to remember your order of operations. 2 times 44, 88.
Oh, wait.
All right. What do you guys think? Michael, do you think you have it?
Yeah, I can do it on the board.
Yeah, I can do it on the board.
I answered that.
Lithia, you can try to get it too. But you have a lot of points, so we have to let Michael try.
So first you do what's inside here. Divide that. So 6 divided by 4 is 2/3. That's the modulus.
Okay, good. I was like,
So you get 3. So that's 22 divided by 3.
no.
No, plus
Sarah.
45.
Sarah, what do you think?
Is it 93?
Oh my gosh, let me finish it. Let me finish it.
No, I got a different answer, but maybe I.
45.
What do you think?
And then you, wait, either.
Yeah, I don't think it's 93.
No? I already have it wrong?
Oh, I wasn't talking. I was talking to Sarah. Actually. Does anyone else want to take a whack at it? Evelina, what do you think?
49.2?
What is it? I don't think so.
9:45.
Okay. Yeah, I did get that. Okay. So order of operations, actually, this is on the same level as multiplication and division, the modulus operator, right? So what's it going to do first?
That's the modulus.
What's it going to give you here? It's going to give you 2. 2 times 42 is, 2 plus 42 is 44.
Oh my god.
Then it comes out here and it's going to go from left to right. It's going to do this. Yeah. It's going to give us 2. 2 times 44.
Do I get the
You guys know 2 times 44. 88 plus
45.
is 133. Okay.
How many was that? How many was it?
I don't remember how many that one was.
I don't think she gave you the point.
Do you know it?
Yeah, that one we had too many guesses. We showed the answer.
I was doing the math.
Okay, Evelina. Pick a good one.
Java in general for 3.
All right, cool. All right, can a class contain both of the following method definitions? This was a 3-pointer.
Oh.
I think we went over this like once in class. This was called overloading your methods.
I don't think it can.
That is right. It cannot. Okay? Because you have to differ in more than your return type. Okay? So because they have the same name, you can do that. But they have to have a different number and or type of parameters. So it's not allowed. So you can't differ in just your return type. So good. Excellent. Good, good. Okay, Valerie. She's still here. Yes, she is. Which one would you like, Valerie?
Arrange 65.
If we were not depleting, we've been at this for a while. Which one would you like? Okay, awesome. 5 points. All right, this is a 5-pointer. We talk about this periodically in here, but not a lot. This is one of those key programming words, actually, encapsulation. You learn more about encapsulation in the second-level programming course. But we did do some encapsulation in here. Huh? What do you guys, does anyone know what encapsulation? Oh, I didn't do my job if no one knows what encapsulation is. Michael, what is it?
Is that when you have like variables in methods?
Yeah, that's part of it.
And then,
So what is encapsulation then?
so,
Think about what that word, what does it sound like?
so,
Yeah, it's encapsulating something.
you encapsulating variables
Right.
in methods, and using methods as variables.
That's kind of wishy-washy. Encapsulation means like hiding code. Encapsulation would be an example of encapsulation that we learned in here is you don't need to know how my method implements. You don't care what's inside the method. You just have to know the method header and you know how to use my method. So you have to know what to send it and what it returns. You don't care how it does it. So it's encapsulating the logic of the method. That's one form of encapsulation. We don't care how the method does it. We just care that it works. When we use system out print line, we don't know how it works, but we know what to send it. So anytime we use a method, we're using encapsulation. Okay? So the ability for someone to use a Java class or a method without having to know how it was implemented. And that one was, a 5-pointer, so. All right. But that is actually an important word in programming. Okay, Lithia. You better pick a 5-pointer. Just kidding. I'm just joking. You can pick any of them. We have one of every point value up there.
Java basics for 3.
Okay, that's a good one. Suppose you create a program called dog.java. When you compile your program, a new file is produced. What format is this new file in, and what's the name with the file extension of this file?
for dot class?
And do you know what format it's in? So we don't look at these files a lot. Eclipse hides them from us. Remember that Eclipse puts our source code in the SRC folder, right?
Yes.
And it puts this runnable in the bin folder.
Yes.
Okay. And it is a dot class.
It's a packet.
I don't think you'll get it. Does anyone know what kind of format it's in? Maybe we ignore this guy a lot. Peter, do you know what format it's in? I know you're not a Java guy. No.
Well, it's probably bytecode.
Right, bytecode.
Oh.
Yes. It is bytecode.
Do I get half of
Byte, like not like you're biting someone, but bytecode. And it is dog.class. Remember, it'll have the same name as your class, but have the dot class extension and then bytecode. Yeah, I'll give you 1 point for that one.
That's 15.
Yes, it is, actually. Good. Oops.
That's 7 questions you can afford to flunk. Like, yeah.
Oh, yeah, that is, actually.
I'm a really bad test taker.
Me too.
Really, really bad.
All right, enjoy. Oh, yeah, Donica is here, yes. Okay, which one would you like? 5 points. What's the name of the Java library that contains the print writer component? Or class, I should say. I shouldn't have put component in there. So we just learned file I/O. Remember, Eclipse does add this for us. So in other words, where do you put in place of that question mark? No. That is a library we use. Alejandro, what do you think? Yes. Okay. Okay, good. And remember, I don't make you memorize things, so that was why that one was a 5-pointer. Sarah.
Yes. Some good Java knowledge, but they I feel like I did that. I don't remember stuff from way before.
Yeah, some of it is from our, beginning of the semester. Can the body of a while loop execute 0 times? Can the body of a do while loop execute 0 times?
I think it was, I remember one in the curve, one in the curve, but I can't remember which one could. I think the do while one could execute. I mean, one time. Ah.
All right.
The while loop can execute 0 times if it's false, right?
Yes.
And then the do while loop is going to execute at least once because you don't, it does whatever is in the loop before.
Good. Before it checks the Boolean expression, but good. Yes. So while loop can execute 0 times if the Boolean statement's never true, but the do while loop checks it at the end, so it has to execute at least once. Okay? All right. Yes.
I'm so happy. I'm good.
All right, Paul. Yeah, let's go. Okay, good one. All right. Actually, this one's not that bad. You can get this. Which one?
It's scaring me.
Sorry, I just can't hear very well sometimes up here. As in boy?
Yeah, is that wrong? Okay.
Oh. Which one looks different than the others?
Oh,
C. So remember, class types are always reference types, actually. So class types are always capitalized in Java. It's a Java standard. So. Remember what this guy's called? He's not a class type or reference type. He is a There's the P.
Primitive.
Primitive type, yes. That's what they call them.
You really studied Lydia like crazy.
No, I didn't.
That is
I
good.
didn't say like crazy, but I wanted to get some points.
That is good. Okay, Jason. All right. All right. What output is going to be produced by our following code here? We've seen this problem before, right? I think. I know I have. Maybe I did take this one out of the lab, actually.
My brain dies on me. How
We have been looking at this for a while, so we have peaked and we are coming down. You know how we can learn so much and then... In fact... So what do you think?
Oh, I thought so.
Well, we kind of have to sort of hurry. So do you have an answer?
Yeah.
Okay, so A, and then A, and then
If they're all A, is that right?
A and A. Yes. And then down here,
A, B1 equals A, A2 equals A, B2 equals B.
and actually, that was the, well, not trick. But remember when two arrays are pointing to the same array of memory? When we point them to the same place in memory, if we change one array, we're actually inadvertently changing the other. So that last one, A2, is actually B. Because they're pointing to the same place in memory. All right. Let's see, how many more people need to go, actually? Not go, like leave. I mean, like, be called. Well, I could just look here. All right. Just because we're, oh well. We still got 15 minutes here. All right, Alejandro.
what's it going more?
Okay, cool. What is a set of clear and precise directions for solving a problem? I know you know this one. Yes, algorithm. Good. I'm glad we got that one right. Definitely need to get that one. Okay, good. All right. And this person's not here, right? Yes. No.
Travis.
Hey, I stole 6 of those mine.
Wait, Travis is... Okay, good. We're jamming through here. Just kidding. Now, Haley, I know, is here. Haley. There's a lot of 1-pointers, 2-pointers. Okay, cool. Okay, what's the output?
I got it.
What is it? No, what is it? What's the output, Michael? It is E. And why is it E? Tell me why it's E.
It's the second one on the screen.
Right, and where do we start with? We start with index 0. Okay. So remember that.
I know.
We always start at index 0 all the time.
I have 2 points, guys. Is that 2 or 3 points?
Actually, that was 2.
It was 2? Oh.
All right, Alexander is not here, right?
Yes!
Okay, just a little bit.
In a row.
Okay, could I go Java concept for 5, man? Let's go.
Man, all in. Oh,
Okay, don't tell him. Do not tell him. Who is the inventor of the Java programming language? We should know who invented the thing we are studying. Don't tell him. Michael, what is it?
Something Smith.
No.
I got it.
give us a stupid you again.
I got it. I got it.
No. Okay, he already guessed, but what is it, guys?
James Gosling.
James
I'm
Gosling.
thinking
Okay.
Smith.
And is he still alive?
No.
Yes, he is. Actually, he has a LinkedIn profile. You can go check it out.
You were always excited about that.
Are you leaving, Peter?
Sorry about that.
Will you stop stealing my points?
And Rebecca? Here, let me get this started. Do you have to leave? In that room. Computers?
I see how it is.
I was doing the final.
A raise for 4 points.
No, I don't think so.
That's fine.
But actually, I know the teacher that's in here, and she'll probably let you come in here if you want.
Okay, I'll just come back.
Okay.
A raise for 4 points.
Okay. All right. What output's going to be produced by the following code? We've got some code here.
Zero, 2, 4, 6, 8, all the way down to 200.
When will it start? When will it stop? Tell me when it'll stop. So 0 to
100. Wait, no, because it's
almost 200, but not 200. Because we're indexed 0 to 99.
oh, right, so 99 times 2, so that would be, yeah.
Don't believe him. She mostly got it right, so I'll give her most of the points. How many points was this? 4? So the first, the first for loop multiplies all of the i's by 2, so it does insert in the array all the, from 0 to 198. And then the second for loop is our for each loop. It just prints everything out. So I was testing a few things. Okay, so not bad. All right, cool. Almost done here. Thanks for hanging in there, guys. I know this was a long one. I usually don't go through all the questions. So, Oh, Juan is not here, yes. Juanita. Since he's not here, we can call him Juanita. The other Gabriel. The other Gabriel. That's his new name. No, we say... All right, consider the following array. What's the last index of A? Notice the index. You can give me his value too if you want. Yes! And then what's its value for extra?
0.
It is 0. You're supposed to let him answer, but okay. But it is 0 because Java does something cool for us and it initializes our array. Because remember, it indexes 0 to length minus 1. All right, Samuel was not here, right? Oh, wait, no, he was here, sorry. Sorry, Samuel. I do remember you were over there. Sorry, Samuel. Okay, which one would you like? For 4 points? Okay, come here. All right, what kind of error is produced by the following code? No. What is it, Alejandro? Oh, I thought you had your hand up. Uh-huh. Does anyone else know?
Yeah, it's a runtime error.
It is a runtime error. Why?
Because we're writing 0.
Good.
Yeah.
I will give you points for that.
How many points is that? Was it 4?
No, it was not 4, was it?
Ah.
I don't think so.
How many points was it?
We'll say 2.
4? Thank you, Lord.
Was it 4?
Oh, yeah. Oh.
But he guessed 1, so we're going to have to take 1 point. Okay, Douglas, we got to you again. Sorry it took so long. Which one do you want? Okay. Okay, write the following mathematical equation and programming code, and yes, you got to come to the board for this one.
Can I do it?
Can I do it?
I need points.
No, Douglas can do
I
this.
messed up on this particular kind of thing one time. Last time, remember?
You don't want to do this one?
I can do it.
Give it to Mike.
Don't let him. You can do this, Douglas, right? I know you can do it.
Why don't you try? And then if you can't, let someone steal it.
I'll do it.
Douglas is doing really good in here. He's a good student. It's okay. It's hard to be on the spot, too. I can't pick somebody.
Should
I have my hand up
I'll just go and do
first.
it.
No, no,
Rock, paper, scissors for it.
no. We'll just.
Too many points.
All right, fine. Who wants it? Who
I'll
wants
do
it?
it.
So this is how you do it.
Oh, man.
No, there was too many. So you can do it 2 different ways. You can use the math.pow or just multiply it out. Okay? Sorry, I didn't want to pick somebody. It is good. Well, no, I just didn't think it was fair for me to, like, pick somebody. Plus, we got to get done here, too. Okay, Andy was here. Yes. Sorry, for some reason I always think you sit over there. Okay, Andy, which one do you want? Okay, cool. What is the value of A dot length? No. What is it? Class? It is 99. Remember, index 0 to 98, length 99. Okay. Length is its size. It's how many variables it has. All right, and Jimmy is not here, right? Oh, who could it be? Who could it be? Oh! Wait, and Lee is not here, right? Oh, who's it gonna be? It's always funny on the last one. Wait, and Lou's here, yes. He's in the back there. Yeah. Wait, which one? The 2-pointer? Okay. All right, what's our output? Switches are beautiful and simple, actually. You should like switches. They're actually really easy to read. What do you think, Lou? What do you think? All right, take a guess. No. I saw your hand up. What do you think? No. And I think we've gotten too many answers to get full points. Now remember, it's in a for loop. So the first time around, n equals 1. So it's going to print 1. The second loop around, n is going to equal 2. So it's going to print 2. The third time around, n is equal to 3. It's going to print 3. Now does it go 4th time around? Yes, because n is less than or equal to 4. So it does go to 4. And when it's 4, it prints out default case. And then it prints after the loop. Okay, so it prints everything. Okay, 1, 2, 3, default case and after the loop. Okay, all right. I Google 1, 2, 3.
That's where number 1.
All right. So I'm going to post these right now. Save them as a PDF. I'll post them to our lectures. Let me stop recording.